Hi guys, this is Mr. Richard. Hope you're well. In this video, we are going to work with sum to infinity of a geometric series. Right, okay. Um, Given a formula, okay, when it comes to sum to infinity, there are two things that we need to take note of. Um, for you to calculate the sum to infinity, there must be two conditions: convergent geometric series must exist, meaning that this is where -1 is less than r is greater than r but lesser than 1. So when it's like this, you can use this formula. You can use, if it's a convergent geometric series, you can use this formula. This formula exists when -1 is greater than r but lesser than 1, so it exists. So if r is greater than -1, or r is greater than 1, it doesn't exist. This is what you should know. It doesn't exist. So this is the two conditions you must have in your mind when you're working with a sum to infinity of a geometric series. Okay, I hope that was clear, right? So now let's go to remember, this formula exists when -1 is less than r but greater than 1. Yeah, right. Okay. Yeah, so we may begin. First thing first, the first question says that calculate the sum to infinity of a geometric GS of a geometric series. Right, the pattern will go on and go on till infinity. First thing first, we have to collect the data. Our first term there, we can see it half. So how do we get there? Remember, we're working with a geometric series. So we are going to say T2 divided by T1, right? 1 over 4 divided by T2. All right, that's half. Definitely R, it's half. Okay. So what we don't know, it's the sum to infinity. Our question says calculate the sum to infinity of a geometric series. So what is missing is the sum to infinity. So you need to apply the formula. Yes, so this since r is at 0.5, it's going there closer to 1. So that means in this case, this series exists. Yes, the geometric it's a convergent series, so it exists. So in other words, we are allowed to use this formula: a 1 minus r, -1 is less than r, it's greater than r but lesser than 1. Yes, -1 is greater than r but lesser than 1. Right, so we can apply now. Where there's a, we shall put half divided by 1 minus half. Okay, when you punch a calculator here, you are going to get 1. So your sum to infinity is 1. In other words, sum to infinity is 1. Done with the first questions, so it's quite easy to apply. Right, so let's go to the second question. These are just typical exam questions. What you should do when you're given such sigma notation: first thing first, formulate a series. Let's place, since our starting point is 1, if we place 1 there, 2 times 10 to the power of 1 minus 1, what will be that? That will be 2. So we will have a series 2 plus, then now let's place 2. What will be that? We are going to get 1 over 5. Okay. Then let's place 3. Okay, let's place 3 now. Okay. That will be 1 over 50. First term, you are going to put 2. Then the ratio will be, okay, 1 over 5 divided by 2, which will give you 1 over 10. 1 over 10, it's similar to 0.1. Okay, so we need to calculate the sum to infinity in this case. So it will be sum to infinity, so equals to a 1 minus r, where a it's 2, right? Minus r, which is 0.1, is also remember, this is a convergent series. -1, it's less than 0.1, and it's greater than 0.1 but lesser than 1. Similarly, even here we were supposed to say -1 is less than half. which is it's greater than half but lesser than 1. So okay, all right, so that's what we were supposed to do in this case. Yes, in this case, right? So let's punch our calculator there. So if you punch this, we are going to get 2,2. So correct it to decimal places. That will be the case. Okay, so let's go to the last question. The last question, we are still calculate or evaluate the series. Calculate. Yes, we have to calculate the series in this case. Similar approach. A, the first term, it's 5 all over 10. What about the ratio then? So the ratio will be 5 all over 10. Okay, okay, 5 all over 100 divided by 10, that will give you 1 over 10. So the ratio will be 1 over 10. So yes, it's converging. Since the series converges at -1, it's less than 1 all over 10 there. It's greater than 1 over 10, but lesser than 1. So we are going to use the same formula. Sum to infinity is equals to 1 minus r. Then we have a. A is what? That's 5 all over 10 divided by 1. Okay, what is our r? R is 1 over 10, or you could say 0, 0,10, 0, 0,1. Sorry for that. Okay, it's because, okay, but yes, you could say 0, 0,1 there. Then what are we going to do? We're going to say 5 divided by 10. 1 minus 0, 0,1 or 1 all over 10. What are you getting there? What are you getting there? You're getting 5 all over 9, right? So the sum to infinity will be 5 all over 9 in this case. Right, guys, so that's it with sum to infinity. For more videos, I will still keep uploading mostly exam typical questions for sequencer and series. Hope you find this these chapters useful. Since I started with sequency and series, we are done. What is left is application and doing more questions. Hope you find this video useful, and don't forget to do the right thing, subscribe and share. Let's grow this community. We are now with 213 subscribers. Let's keep sharing. Let's grow this channel. Let's take it to 1K. Our goal is 1K, so that we grow this community step by step. Don't forget to subscribe and like and share. We love you.